Hi, everyone. Thank you for coming today. My name is Jessica Moe. I'm a summer 2023 NASA intern with the GLOBE team. And today I'm going to be presenting on open data for citizen science, a discussion on GLOBE observer quality flags. So a little bit about GLOBE. I know that everyone here is very familiar with GLOBE, but I'd just like to emphasize that GLOBE is arguably the most comprehensive citizen science initiative for geospatial data. It's sponsored by NASA, implemented by UCAR, and supported by the NOAA, the NSF, and the Department of State. So to date, since its foundation in 1995, more than 238 million measurements by citizen science have been uploaded to the GLOBE database, and this data is also publicly available. So a little bit more about GLOBE Observer. It's the mobile app for iOS and Android that was launched in 2016. So since 2016, even more people have hopefully been able to make GLOBE observations that are included in this GLOBE dataset. And so just a little bit more of overview, as I'm sure all of you are pretty familiar with the GLOBE observer data. There are 4 protocols: clouds, mosquito habitat mapper, land cover, and trees. And so in general, these protocols will include the protocol-specific measurements as well as information on the longitude and latitude of the observation, the date and time, and possibly any directional photos that are associated with the observation, especially with clouds, mosquitoes, and land cover. So a couple goals for summer 2023 were to implement new quality flags for this GLOBE data and to write and supplement documentation for these quality flags, so that people in the future can make changes as they see fit or leverage these quality flags as they see fit. So in general, why do we need quality checks? Well, number one, big data often requires quality measures and cleaning, and with more than almost 240 million measurements, GLOBE does count as big data. Notably, researchers in the past have leveraged GLOBE data for publications, and higher quality input, that is the data, will lend itself to higher quality output in the scientific analyses. So this summer, I built upon previously published work by Helen Amos et al. On quality checks on GLOBE data, with the end goal being to put into production the routinely cleaned up and flagged data on the GLOBE website, so other researchers or end users for GLOBE can more easily access it. So in order to implement these new quality checks, I obtained the data from the GLOBE API, ran the data through a Python pipeline, and through it all, I used GitHub for version control. So a couple of potential data concerns that we wanted to watch out for in particular were, number one, observations submitted as a test. Naturally, you wouldn't want to include these observations as valid data. We also don't want to include typos or misclicked in manually entered data. We don't want to include measurements that are likely to be inaccurate. We don't want to include fields omitted or entered with quote-unquote dummy data. And we also know that if there are repeated data fields or photos in the observation, at least one of these fields or photos has to be potentially invalid. So with all of that in mind, we implemented a couple of new flags. A few examples of these are number one, if latitude and or longitude are integers. So this doesn't necessarily mean that this lat-long set is invalid. It just means that perhaps we might have to be a little bit wary about the accuracy of this data set. Since it is possible to manually enter lat and long, and since we also want to be inclusive with these Globe Citizen Science databases, we just want to flag these, but not necessarily provide a judgment on whether, these are accurate enough or not accurate enough to include or exclude from the potential analysis that might be done by the end user. Another flag that we want to implement is if latitude and longitude exactly match. So again, this doesn't necessarily indicate that there is a invalid geocoordinate set here, but we also want to mark if the user accidentally entered the same value for longitude and latitude if they weren't supposed to be the same value. We also want to see if observations may have been taken over a lake. We want to see if 8 or more of the 10 cloud types in the Globe Observer options are marked as present, simply because this is fairly rare based on our own analyses of Globe Observer data. And so we want to catch any observations that might have involved users just checking off a lot of different cloud types, or we might want to indicate which observations might have potentially very interesting geospatial phenomena that would result in so many cloud types being present at once. Finally, we want to flag if there are duplicate photos within the same observations for those observations that have directional photos, because naturally you want to expect the same photo for north and south or east and west, etc. So a few other notes that I also wanted to point out is that flagging the data does not remove any data or change the globe data in any way. It's mainly so that these flags can guide researchers so they can see which data may warrant further examination in order to, again, identify potentially very interesting geospatial phenomena, or to see which data they want to include or exclude in their input for their scientific analyses. So I generated a few summary figures for the month of May 2023 with these new flags. So this figure is the geographic distribution of Globe Observer observations for May 2023. So as you can see, most of the observations are pretty concentrated in the United States as well as Europe. So this just gives us some insight into which regions more commonly use GLOBE. I think that naturally, since NASA is a US organization, we might expect more GLOBE observer observations to come from the US. But it's just interesting to see the entire geographical spread of who is using the Globe Observer app and submitting observations through that app. So this is an explanation of all of the flags currently we have in play for our quality check process. So you can see that there are flags specifically for cloud cover. So the clouds protocol, there are flags specifically for date and time and elevation, which are common to all 4 protocols. Latitude and longitude checks, which again are all common to all 4 protocols. They're flags specific to mosquito habitat mapper protocol. And then finally, there are also flags for land cover again, and then tree height. So onto figure 2, this shows the absolute number of Globe Observer observations that raised quality flags. So we can see something pretty interesting here, which is that the most common quality flag raised is LW, which indicates that the location may be over an ocean. And of the LW flags, clouds represented the biggest proportion of those observations that raised the flags. Part of this may be because there are simply a greater number of clouds observations compared to the other 3 protocols. But also importantly, clouds observations we have seen in the past that clouds observations have been taken over boats or yachts on the open ocean. And so this doesn't necessarily mean that we would be immediately suspicious of these observations, but it does give us information on what type of other factors such as, like hydrodynamics that might be impacting these clouds observations. So in this way, this will give you researchers a fast way to determine very quickly some other relevant information about all these observations. And if we move on to figure 3, this is the percentage of globe observer observations with quality flags. So for this figure, essentially these percentages are calculated by doing the number of observations with flags raised over the total number of eligible observations that could have had that flag raised. So this gives us some more interesting information because, again, we can see that almost 10% of observations do have the LW flag raised, but actually the more commonly, relatively speaking, raised flag is the MI flag for mosquito larva count is invalid. So this is when larva count is, for example, says null in the GLOBE data set. So this provides us some potentially useful insight into how users interact with the Globe Observer app. For example, it might be the case that users can skip over reporting the number of mosquito larvae, and then they're still able to submit that mosquito observation, in which case the flag could be raised. So knowing this, it does raise some interesting questions about how we might reduce the number of occurrences of this, as well as how future changes might be implemented for the Globe Observer app. So just to reiterate, a couple of takeaways from these quality checks is that number 1, most observations are not flagged. And number 2, the most common flag by absolute numbers is LW, location may be over an ocean. Number 3, a high proportion of mosquito observations have the MI flag. And in this way, using quality flags can provide insight into app design. So I just want to focus on one specific use case of one of the new quality flags, which is the lakes quality flag, indicating whether if an observation may have been taken over a lake. So the lakes quality flags doesn't necessarily indicate an error. Similar to the LW, location may be over an ocean quality flag, people can report observations like land cover from small boats in the middle of the lake. And clouds observations are also fairly commonly taken over bodies of water. So the lakes flags allows researchers to more closely examine the observation before deciding whether or not to use it. And it might have an interesting research potential use case in which if a researcher is studying cloud geophysics over inland bodies of water, and thus they're interested in cloud dynamics, they might be specifically interested in observations marked with a lakes flags. For example, this top picture shows a phenomenon called cloud streets over Lake Superior, one of the Great Lakes. And so cloud streets are a geophysical phenomena that do commonly or do notably form over lakes. So if a researcher were particularly interested in cloud streets, then they would be easily able to narrow down the eligible observations that they want to use in their research data set by stratifying for only those clouds observations marked with the lakes flag, LL. So in terms of future directions, one potential avenue that we'd like to explore is using different data sets for lake boundaries. Number 1, because lakes can grow or shrink over time due to phenomena like climate change. And number 2, because different data sets may have different criterion for determining what is or is not considered a lake. So depending on the researcher's preferences, they might want to use different lake polygon data sets. Number 2, we'd like to speed up the processing time for detecting duplicate photos. Relatedly, we want to detect any duplicate photos in the GLOBE dataset, regardless of whether the photos are in the same observation or not. So in conclusion, GLOBE is again arguably the most comprehensive geospatial citizen science database in existence, with almost 240 million observations. And the usage of quality flags is up to the end user or researcher. Quality measures can detect potential geospatial phenomena of interest, detect suspicious data that you might want to exclude from your analysis, and also give insight into how users interact with the Globe Observer app. In conclusion, quality flags will allow us to better leverage the hard work of scientists around the world. So before I end the presentation and open it up for questions, I'd like to give a quick shout out to the team I worked with this summer. I was mentored by Kristen Weaver, Holly Cole, and Dr. Agnes Conati. And my team also included Heather Mortimer and Sid Josti. I'd like to thank everyone for your wonderful support, guidance, and mentorship as I grew and learned through the internship. And thank you everyone for listening to the presentation, and please feel free to ask any questions that may come to mind.